This is an example of a limiting reactant problem for 7.2 basic level and meets level. So as we go through, I'll differentiate between what we consider the basic level and what we consider the meets level. To start, the reaction for zinc oxide is 2 zinc plus oxygen yields 2 zinc oxide. Suppose that 4 atoms of zinc and 4 molecules of oxygen gas react to form zinc oxide. Make a drawing that represents the containers before and after the reaction. So before the reaction, I have 4 atoms of zinc. I'm going to color that in and make it a blue particle. And then oxygen comes as O2 because it's diatomic, and so I'm going to leave that open and show it connected. So that's my beforehand. After, for every 1 zinc, there's 1 oxygen. So I'll start again with my 4 zinc atoms, which are now connected to 1 oxygen atom each. I've now used 4 total oxygen atoms, meaning I have 4 left. If I look at the bottom, how many molecules of zinc oxide can be produced? Well, we have 1, 2, 3, and 4 total molecules produced. And which reactant is in excess? Well, excess means left over, and O2 is in excess, and we have 2 molecules of it left. That brings us down to our definitions. So for limiting reactant, the definition for limiting reactant, which you'll probably see me abbreviate over and over as LR, the limiting reactant is the reactant that limits how much product can be produced Important things to know is that the limiting reactant runs out first. And it stops the reaction. I'm going to abbreviate reaction here, RXN. When it's gone. The excess reactant, which you'll probably see abbreviated as ER quite frequently, is the reactant that's left over after the reaction stops and the limiting reactant is gone. And your last term is theoretical yield, and that is the stoichiometrically calculated amount of product you can produce based on your limiting reactant. So limiting reactant runs out first, excess reactant is left over once the reaction stops, and the theoretical yield is the stoichiometrically calculated amount of product that you can produce based on your limited reactant. Now let's try some practice problems with that information. So problem 3 says the heat from an acetylene torch is produced by burning acetylene C2H2 in oxygen. And this is a basic level problem. So how many moles of water can be produced by the reaction if 2.4 moles of C2H2 react with 5.4 moles of O2? So the first thing that we're going to do is start with one of our reactants. I'm going to start with 2.4 moles of C2H2. am wondering, with this much C2H2, how much water can I produce in the end? So here's my water. I'm going from C2H2 into water. And so the only thing I can do here is go from moles to moles. For every 2 moles of C2H2, I produce 2 moles of water. If I take 2.4 times 2 divided by 2, I get 2.4 moles of H2O as what I can produce. That's if I use all the C2H2 that I'm given. I have another option. Instead of using the C2H2 I'm given, I could use all of the oxygen I'm given and turn that into water. And so let's try that. If I use 5.4 moles of O2, and then I look at my coefficients in my ratio, for every 5 moles of O2, I can produce 2 moles of H2O. And if I plug that into my calculator and I take 5.4 times 2 divided by 5, I get an answer of 2.16 moles of H2O. And so the question is asking us, what's the limiting reactant? The limiting reactant is always going to be the reactant that runs out first. And so in the situation that we just solved, the limiting reactant will always produce less product, right? When it runs out, you can't make any more product, and it's going to therefore limit you. If you use all of your oxygen, you get 2.16 moles of product. If you use all of your C2H2, you get 2.4 moles of product. Well, by the time we reach 2.16, we don't have any more oxygen to react, therefore we can't get to the 2.4. So, what is the limiting reactant for the above reaction? The limiting reactant is the reactant that produces the lowest amount of product, which in our case is 5.4 moles of O2. Specifically, your limiting reactant is going to be O2. What's your theoretical yield? That's how much you can actually produce. So here's where that 5.4 moles comes in. And then what's the excess reactant? The reactant that there is some left of at the end. The excess reactant is C2H2 because it produces more product.